Hello everyone! Today we're going to be talking about application to solving inequalities. In this first video, we're going to be looking at writing an inequality from words. And so with each of these inequalities, there are several phrases that can represent that. For our greater than inequality, we of course have greater than, and we also have more than. For the less than, we have less than and fewer than. For greater than or equal to and less than or equal to, we have a couple of different phrases. So for greater than or equal to, one common one that you'll see is at least, and another one that you'll see is no less than. Both of these mean greater than or equal to. For our less than or equal to inequality, we have at most, which we'll commonly see, and no more than. So when you're writing an inequality from words, these are some key phrases that we're going to want to be on the lookout for. So let's look at some examples. I have a number minus 4.5 is less than or equal to -3. And so for this one, it tells us what the inequality is. It's less than or equal to. And so I can go ahead and write this out. So I have a number, which we'll just represent as x, minus 4.5 is less than or equal to -3. And I can go ahead and solve that. So I'm going to add 4.5 to both sides. And I get that x is less than or equal to 1.5. Okay, let's look at this next one. So this next one says 3 is less than a number plus 6. So here my inequality is the less than symbol. So I have 3 is, which is just is less than a number, which we can say is x, plus 6. That's all for x. I'll subtract 6 from both sides. And I get -3 is less than x, and if I switch that around, that's the same thing as x is greater than -3. Okay, this next one says 11 is at most twice a number plus 1. So I think at most, what inequality does that match with? And I see that is in the less than or equal to. And if you think about it, that makes sense. When I say at most, that means I don't want anything greater than that. I want it equal to it or less than. So if I write this out, this will be 11 is at most, which is less than or equal to, twice a number, which is just 2x, plus 1. Now I'll solve that. I'll subtract 1 from both sides. And I get 10 is less than or equal to 2x. Divide both sides by 2. And when I switch that around, I have x is greater than or equal to 5. Okay, let's look at one last one. So this one says -7/10 is at least twice the number k minus 4. So at least, that means greater than or equal to. When I say at least, it means I don't want it any smaller than this. So when I write out this inequality, I'm going to have -7/10 is greater than or equal to twice the number k, which is just 2k minus 4. And now I can go ahead and solve this. So I'm going to add 4 to both sides. Now this doesn't have a common denominator, so I first need to have a common denominator. So I have -7/10 plus, I multiply top and bottom by 10. I have 40 over 10. And now when I add my numerators, I get 33 over 10. It's greater than or equal to 2k. And then I can divide both sides by 2, or that's the same thing as multiplying both sides by 1/2. And so I get that 33 over 20 is greater than or equal to k, which is the same thing as k is less than or equal to 33 over 20.